Hello students, you're welcome to this tutorial on calculus. So firstly, we are going to be given a brief introduction of calculus. One of the first things that you need to know is that calculus has two major divisions, which is the differential calculus and the integral calculus. Now, both the differential and integral calculus comes from the basic fundamental concepts that we have in mathematics, which is BODMAS. Now, we know that BODMAS in mathematics simply means brackets of division, multiplication, addition, and subtraction. Now, earlier on, I told you that we have two major divisions, which is differential calculus, and we have integral calculus. Now, I've told you that both differential and integral calculus is based on this major principle that we follow in mathematics. Now, in differential calculus, we go in this direction. We can call it the right-hand side direction. This for differentiation. If we are differentiating, you are following this direction. Integration is the reverse of differentiation. So it's going to be in the reverse direction. So if you are going in the reverse direction, this is integration. So we have derived two things now. Firstly, differential calculus is the opposite of integral calculus, vice versa. Integral calculus is the opposite of differential calculus. And both of them are based on the major principle of BODMAS. If you are going in the right hand side, that you are differentiating. If you are going in the left hand side, you are integrating. So now, what are we actually doing when we are going on the right hand side? For differentiation, you multiply before you subtract. So you can see here in this direction, multiplication comes before subtraction. We call it the MS method. For differentiation. Now, the reverse of this, if you are multiplying before you are subtracting here, if you are coming from the opposite direction, it means you will need multiplication and subtraction. So you are adding before you are dividing. We call this the AD method. So we have derived something now. Integration. We use the AD method. While for differentiation, we use the MS method. Now, in calculation terms, what do we now mean by the MS method? What do we mean by the AD method? The MS method, as it implies, you multiply before you subtract. For example, let's assume that you are given a function y is equal to 3x squared. If we are to differentiate this with respect to x, we refer to it as the y dx, which is pronounced as dy dx. So here, the y over dx simply means that you are differentiating y with respect to x. You are differentiating y with respect to x. So here we are using the MS method. We multiply first, multiplication first. What are we multiplying? We multiply the coefficient by the power. The coefficient here is 3 multiplied by the power, which is 2. Then you subtract 1, which is the s. The first thing, multiply the coefficient by the power, which is 3 times 2. Then you subtract 1 from the power. So this will be times x raised to power 2 minus 1. So here, our dy dx is going to give us 6x, because 2 minus 1, that will give us 1. So it means that when we differentiate 3x squared, we're going to get 6x. Now, since integration is the reverse of differentiation, it means that if we integrate 6x, we are supposed to get what we differentiated, which was y is equal to 3x squared. So from here, if we say that dy over dx is equal to 6x, if dy over dx is equal to 6x, if we cross multiply, the y will give us 6x dx. Now I want to integrate, so integrate both sides. Integral the y will give us integral 6x dx. Now, where that sign integral comes from is that definition of integration normally, aside being the reverse of differentiation, integration is a continuous sum. So if you consider the word sum, the first letter, which is s, giving you that elongated s. So from here, since we have integral the y is equal to integral 6x dx, since differentiation is the opposite of integration, it means that if we differentiate y and we find the integral, we are going to get that same y. So just as a remark, if you integrate du, you are going to get u. If you integrate dv, you are going to get v. If you integrate dp, you are going to get p. If you integrate the anything, you get that thing. So from here, if you integrate the y, you are going to get y. Now, when we get deep into integral calculus, we're also going to know what we refer to as definite integrals and indefinite integrals. So, but this is an indefinite integral, and the major difference between a definite integral and indefinite integral is that definite integrals are integrals that comes in this form. You'll be given a lower boundary and an upper boundary. But for indefinite integral, you're just going to have the integral sign. So your final answer will always have an arbitrary constant c, or you can use an arbitrary constant k. So this is an indefinite integral, but it means we need to integrate these. Now we are integrating 6x with respect to x. We use the AD method. We add before we divide. Now what are we adding? We add 1 to the power, then we divide by that new power. What we have there already is 6x. The power of x here is 1. So if we add 1 to the power, that will give us 1 plus 1, divided by that new power, which is 2, plus arbitrary constant c, because it's an indefinite integral. So our y is going to give us 6x raised to power 2 divided by 2 plus c. Our y is going to give us 3x squared plus c. So basically, this are an arbitrary constant c. So our y is 3x squared, which was exactly what we differentiated. So basically, that's like one of the major bases of differential and integral calculus. For example, let's consider another example. If we have y is equal to 32x raised to power minus 2, and we are told to integrate, to differentiate y. So here, our dy dx will give us, we use the MS method, you multiply the coefficients by the power, you write this letter, then you subtract 1 from the power, which will be minus 2 minus 1. So our dy dx here is going to give us 32 times minus 2 will give us minus 64 x raised to power minus 3. So our dy dx here will give us minus 64 divided by x raised to power 3. So it means that when you differentiate y is equal to 32x raised per minus 2, the y dx is minus 64 divided by x raised per 3. Now, basically, in mathematics, if we have a function y, let's say y is equal to f of x, basically we know that y is always equal to f of x. Now, we are making use of two variables here. The first variable here is y the second variable is x. F is just a function of x. Now, there's what we call a dependent variable, and there's what we call an independent variable. Now, if y is equal to f of x, for example, let's say that your function y is defined by 2x squared. It means that for every value of x, you are going to get the value of y. If your x has a range of values, let's say 0, 1, 2. Now, these are the range of values which are actually independent because they don't depend on the value of y. If your x is 0, your x is 1, and your x is 2, your value of y depends on this function, which is 2x squared, which is going to make your y your dependent variable. So it means that if you have y is equal to f of x, y represents the dependent variable, while x represents the independent variable. So y represents the dependent variable, y x represents the independent variable. So for here, x, these are the values, these are the numbers that are independent, they are the slotted data. When you now substitute those values of x here, your y depends on those values of x. So it means that when your x is 0, your y also will be 0. When x is 1, that will be 1 raised to power 2 times 1, which will give us 2. When x is 2, 2 raised to power 2, that's 4 times 2, that will give us 8. So the values of y, which is 0, 2, 8, depends on the value of x, which is 0, 1, and 2. Now, basically, in the next tutorial, we are going to start limiting value of a function, and which is very, very basic. We are starting first with differential calculus. Then as the tutorial progresses, we are going to enter integral calculus. Then we'll dive into application of differential calculus and application of integral calculus. So we have come to the end of this introduction tutorial. Thank you. See you in the next tutorial.